Okay, welcome everybody. Thank you very much for giving me your Thursday lunchtime. Welcome to another Architecture for Innovation Lunch and Learn. I'm very pleased to have Daniel with us. I know we've been speaking to Daniel for a little while now. I'd be quite keen to get him on board. So I suppose just before we start, I just want to give you a little sort of rundown about where I'm seeing the architecture market at the moment. There's also been quite a bit of change, still a lot of chat around AI. I think there's a little bit more uncertainty this month than there maybe was last month about where things are sort of heading. I think, as I mentioned in the last meeting, I'm still seeing quite a lot of fractional work starting to come through, and a few more conversations around architects doing sort of 2-3 days a week. So there seems to be a lot more encouragement around that. We're also talking a lot more around governance around AI and how that's going to affect us all. It's becoming a little bit of the Wild West, and bringing that back to make sure there's a lot more governance around that. So it seems to be the conversations we're having in this sort of couple of weeks. It all seems to be promising sort of future outlook, but just at the moment, I think people are a little bit cautious of how things are running. So I'd like to introduce Daniel before we start. So we'll probably do 20 minutes, half an hour presentation by Daniel, and then after that we'll sort of go to a Q&A session. So feel free to put any questions into the chat box, and then we can go from there. So Daniel is, so how do I, I'm not quite sure how to introduce you because there's so much that you've done and there's so much you cover, but Daniel is a mechatronics engineer turned to cybersecurity specialist and the founder of Skadi Solutions. They deliver cybersecurity services to critical infrastructure and building automation environments. His career spans robotics, systems engineering, cybersecurity at both enterprise, across enterprise and IT, operation technology. Daniel previously served at the Australasian Signals Directorate, supporting national resilience uplift initiatives. He's since led and advised architecture and engineering engagements and translates governance into deployable operational grounded controls. He's known for bridging security engineering and operation teams to deliver practical, measurable uplift, resilience, and performance. But I hope that did you well, Daniel?
That's good. Thank you.
Over to you.
Great. Well, I'll share my screen. This one. Hopefully you can all see it. Yeah, cool. So yeah, thank you again for having me on the forum. This is my first time, maybe not the last time, but it's good to engage with the architecture group on a topic that I really feel strongly about, which is around architecture for critical infrastructure, specifically the idea of defensible architecture for critical infrastructure. So yeah, we're going to go over that concept and talk about, I guess, what does that look like as a target state, operationalize things like isolation for critical infrastructure, and ultimately, how do you build a critical infrastructure environment that can actually continue to operate despite the fact that there are threats and compromise already within the environment. Yeah, so quick background, I think it was mostly all covered, but yeah, I've been in the IT/OT cybersecurity industry for around about 8 years now. I've worked across multiple different sectors. So I was a mechatronics engineer, and that's sort of the basis for my background in control systems, but now I primarily focus on the security side of things. And yeah, I've done some cool stuff with AEST intelligence, working with large critical infrastructure organizations across water, waste, electricity, and yeah, now I'm the director of my business, Skadi Solutions. Maybe just a quick background on Skadi Solutions. So yeah, again, we do resiliency uplift for critical infrastructure. It's primarily cybersecurity advisory services, looking at things like uplift assessment, roadmap development, attack surface management using tooling, and secure architecture is a big portion of it as well. So working with complex IT/OT integration, helping organizations do that in the right way. Quick agenda. So I'm just going to give you starting point just on what is critical infrastructure, why is it relevant, the threats and the activity that's generally in that sort of space. Then I'll dive into the actual core topic, which is the more, when I'm thinking about doing architecture for critical infrastructure organizations, the principles and the prompters that I think about. And then conversely, the anti-patterns and the pitfalls that can really compromise these architectures when you're developing them. I'll go through a worked example of what a good target state architecture looks like and how you actually use that to do recovery and isolation, and then I'll open up for the questions. So critical infrastructure. The problem space. So it basically, when we talk about critical infrastructure, it's the systems that deliver essential services for everyday life. So things like electricity, water, transport, healthcare, waste processing, any of these things stop operating or hell breaks loose, basically, because it's the fundamental things that we need to operate as a society. They're not just business systems. They're really a combination of enterprise systems and physical engineering processes, which is where the control systems element comes into that. When we talk about the general sort of taxonomy or topology of a critical infrastructure organization, we're generally talking about the concept of IT, so information technology, and then operational technology, OT. In some instances now, we're also dealing with IoT, so things like smart sensors at scale, fleet vehicles, telematics, this sort of stuff. So these are all characteristic of what you would see in a critical infrastructure environment. A traditional environment from an architecture perspective, you're going to see things like air-gapped strategies to try to maintain that sovereignty and that separation from the, I guess, the back of house corporate functions versus the actual control systems that operate the process. So things like stepping up or stepping down the voltage, twisting a turbine, opening a valve to release chemicals into a waste, into like a water vat to sanitize it. So all these processes are driven by the same computerized technology. The difference is that we're talking about that in an industrial context, and using that to move an actual physical process. Now, when we talk about modern environments, we're still talking about the same stuff, right? We're talking about PLCs, RTUs, SCADA, DCS, these types of assets. But the reality is that the air-gapped approach is not really feasible in this day and age. And it's just the requirements of the interconnectivity that come with us being in a modern organization. People want to do things like extract intelligence from these networks to perform predictive maintenance. So they want to know when assets are going to fail before that happens. They want to take data and derive insights around how the operations are performing, how workforce dispatch is operating, all these types of things. So they need to get that data out of the operational environment. There's ML components, and in some cases, even some organizations are looking at driving control decisions based on that data aggregation. Remote operations and centralized control is a massive one. So obviously with fleet moving to a more decentralized state, so we're operating from multiple regional places in the in Australia, and we're decentralizing the geography, but we're centralizing the control. So everyone comes in through one central plane and monitors things from one central system. So in order to do that, you can't just run local DCS on a site-by-site basis. You need to take those sites and you need to connect them back up to a central control center. And then the last one is vendor remote access, which is obviously a major part of maintaining and supporting these field environments. So to maintain your warranty and ensure that you're going to have support for these systems, you need to be able to provide vendors remote access, and in some cases connect field sites to managed services that are run as SaaS. So this is just the reality of the world that we live in. So because of that, we have to change the approach by which we and how we do architecture for critical infrastructure. So the topic for today is on designing defensible architecture for critical infrastructure. It's really about, number one, what are the architectural principles that make resilience possible? I'm going to talk about resilience a lot. It's a really core theme to this whole thing. The second is, what are the anti-patterns that can destroy that defensibility? And then how do you apply this to real containment and isolation scenarios? So what I really want to address is questions like, can I separate my corporate IT environment from my OT without shutting down operations? Can I still provide remote access without, can I disable remote access in the event of an incident, but still be able to manage and maintain the site? And can I rebuild as well? So once I've isolated, am I able to actually rebuild from scratch when I no longer trust the environment? So again, the reality with this whole thing is that, yes, there is an active threat landscape when we talk about critical infrastructure. It's really starting to shift towards an actual, and this is sort of an extension of the geopolitical climate, right? Like, in addition to kinematic based attacks, there is also a cybersecurity component. Are we going to enter a world where cyber warfare is sort of how war is done? I don't think so, but it's hybridized, right? So it's a multilateral approach. And when we think about like we don't know for sure whether that was done, but there was a lot of evidence to insinuate that when the US invaded Venezuela, that was a multilateral attack that involved things like actually turning off the power through cybersecurity means. So you're seeing that sort of multilateral strategy play out in real time. And of course, a lot of messaging is coming from the government as well around groups like Volt Typhoon from People's Republic of China, that they are doing things like pre-positioning in these networks to deliver that sort of capability. And then, of course, you have the commoditization of malware as well. So not just IT malware, but OT specific malware that can make it easier for those lower skilled actors to actually cause impact in critical infrastructure. So we acknowledge that all of this is happening. There's a lot of threats. There's a lot of activity. I really like this idea of resilience is not the absence of threats, it's the ability to keep operating while threats are present. So if I just, let's just accept that I'm going to get attacked. And if a nation state really wants to destroy everything, it's going to happen. There's not much I can do about it. So there's a lot of messaging from federal government and from, I guess, from the OT security community to say, let's assume that, let's just assume breach, and let's make ourselves resilient or impermanent to that. So can I actually forget about the threats and just prioritize those three key aspects, which is I use SRP, which is safety, reliability, and performance. So can I maintain these three priorities amidst all the threats? So there's two key pieces of material that have come out recently that really talk to this. One of them is Fortify. So the key messaging there is 3 months of isolation, which is a big ask, but it's something that has been stated by the government. And then the other one is the whole rebuild from scorched earth. And then more recently is the consultation paper that came out from the federal government that basically mirrors that guidance. So that guidance is actually shifting into actual legislative obligations now. So in order to isolate for 3 months, that's an architectural capability that needs to be delivered. So defensible architecture, it's mentioned in a lot of standards, it's mentioned pretty much everywhere in different ways. There's some stuff there. It says build a defensible environment, 9%, efficiency. I think it should be probably higher, but that's what CISA says for their 7 steps to defend ICS. But the point is that it's mentioned in multiple pieces of literature. To explain defensible architecture, I like this analogy with sort of trench warfare. So it's the ability to actually have defensible positions to fall back to, establish boundaries, give you those choke points to be able to slow down and contain the movement. So you can move back, and then you can advance and move forward as you sort of gain that control back. And that's effectively what we're trying to establish when we talk about this defensible architecture capability. So the 5 principles that we're going to go through today that support rapid isolation and rebuild procedures. First one is this concept of OT sovereignty. The whole idea of OT sovereignty is basically to build some level of minimum independence from the corporate IT environment to be able to still administer, operate the environment without being critically dependent on the IT environment. And that's really important because the IT environment really presents the largest threat surface, and that's where most threats begin. It's this idea of coming into the IT, establishing a foothold, and then pivoting into OT. So if we're able to manage that boundary point, then that's going to give us a lot of value against things like phishing, credential theft, all that type of stuff. Part of that starts with asset classification and inventorization. So understanding what are the assets that you would consider sensitive, or other people use the word crown jewels, sort of as a guideline. There's some there, right? Like things like management tier infrastructure, backup servers, domain controllers. These aren't PLCs necessarily, but these are keys to the kingdom. So this is the stuff that you need to think about building those boundary points around. And then of course, even things like information. So things like OT configuration files for PLCs, all that type of stuff. And questions you can ask are things like, well, where does the control equipment configuration actually occur from? So that's a very good question to ask, because you might find that there's capability to actually administer OT engineering, programming, things like that from the IT environment. And that's where we have an issue, and we need to start looking at rectifying that. And then also what assets are being used. So again, is it a corporate machine, or is it an actual engineering jump box in a specified zone? Purview is talked about a lot. I put it there just because it's not to say that this is how you need to do, and that's not the point of Purview. Purview is supposed to give you an asset framework around how to classify assets, which is nice because it gives you some guidance around how you could set up those zones, but it's not necessarily a one-to-one relationship. So yeah, Purview is normally sort of misconstrued as a segmentation framework, where it's not that. Number 2, restrict IT/OT interfaces and data flows. Oh, sorry. This is really about that idea of limiting the blast radius. So limit the blast radius and then identify the points where the isolation can actually be performed. So typically the firewall points, like these are where you would be doing isolation, but it's not the only way that you can do it. They're also really great choke points to do things like inspection. So then you can make that proactive decision to, for example, isolate. Now, I spoke about a lot of the interconnectivity use cases, and that's the reality, things that you might encounter, things like ad hoc transfer of files, real-time data transfers, remote access workflows. So these are the things that are gonna push you towards breaking those points. So if it's too hard to get the connectivity, then they're going to put a 4G router and they're going to make their own pathway to achieve what they need to achieve. So it's about building centralized, repeatable blueprints and patterns, so you're not having that conversation. The architecture is actually developed to cover off a lot of those key use cases. So if someone wants to transfer a file, here's the pattern around how we do that securely. Or someone wants to access the internet, here's how we do that. And there's a few other things in there. Just preferably, you want to make OT the authoritative source. So you're looking at pool-based or pool-based from your OT, as opposed to corporate pushing in. So there's some nice guidelines there listed for that. Number 3, operationalize shields up. Now, this is sort of talking to that whole isolation that is now being, like, I wrote this quite a while ago, and now, like I said, it's actually approaching the point where it's actually being considered as legislation. So it's no longer a choice. It's something that CI need to actually do. Key isolation points that you might consider would be IT to OT, IT to the internet. OT to OT is another one that's typically overlooked. So that east-west segmentation, sometimes people sort of, they really protect IT and OT, and then they don't consider the idea that an OT environment could actually infect another OT environment. So when we talk about defensible architecture, it's really about operationalizing these isolation use cases, and building a level of flexibility so you can actually make conscious decisions to slowly degrade the environment without just pulling the cable. This idea of like, I'm under attack, so I'm just going to rip the big red cable out, and then that's going to cut me off from the internet. That's something like that. You run the risk of basically killing all the dependencies that are there. So this is what a lot of the guidance talks about. It talks about understanding the dependencies, understanding the internet connectivity, so you can make conscious decisions around how you actually disconnect and isolate, and do that in a granular fashion. So if it's just one site that's infected, you want to be able to make quick action to isolate just that site. Or maybe it's just a subset of your corporate environment. Maybe you don't need to totally isolate IT and OT, maybe just a portion of that. So once you've built that, then it becomes more thoughtful, the way that you can segregate. And it all comes down to mapping those dependencies. Oh, my cat is here, sorry. Number 4. So I spoke about this triad before, the safety, performance, SRP, so safety, reliability, and performance. So this is just a sort of additional call out just to consider this is a central component when you're building up architectures for critical infrastructure. This idea of determinism is really the key behind all of this. You want to be able to have things fail in a deterministic way. So I unplug this cable, or I isolate this host, and I know exactly what's going to happen. So I'm making a conscious decision, and I actually build that into my designs. So I'll have, like, as part of like a disaster recovery and or availability section, I will write about these are the isolation points, and when I disconnect, for example, a Kafka interface that's mirroring traffic, now I'm losing my ability to pull in telemetry into the environment. So I can't do forecasting, but I can still control the assets. So I'm degrading the solution, but I'm still able to operate it. So being able to communicate that is really important. So then you've got that determinism. I've seen cases where sometimes cyber incident response actually makes the incident worse. So something like disabling a service account and not understanding the impact that has on the broader environment can actually cause more chaos. Maybe it was just one site that was infected. Now all your sites are dead because you turned off your service account. And there was a point on the last slide about sort of culture and engaging with the actual engineers that operate these sites. Approaching it from this perspective of SRP is really going to help with enabling that relationship and that collaboration, because when you want to make changes to the environment, you need to understand that cyber isn't the first thing they think about, but safety, reliability, performance is the language that they understand, and they're going to be more willing to work with you when you come at it from that perspective. Now, this is the last one, which is implement proactively, or I guess plan for the future. Architectural change is not something that happens quickly. In critical infrastructure, let alone government, that's even slower. So it takes a long time to make these architectural shifts. And typically these happen in response to an incident, right? Like once an incident happened, that is the catalyst to drive a lot of these decisions. So the point is you can't just make defensible architecture happen on like during an incident, definitely not going to happen, and following an incident, it's going to take time. So you want to be doing that whole exercise proactively and actually building that as a program of work. And it is highly disruptive. Like, we're talking about network segmentation changes. We're talking about unplugging things, maybe re-IPing devices. It's a highly disruptive process. So this needs to be done as a program of work. And you may also need procurement as well. So maybe you need to buy some firewalls. Maybe you need to procure some SD-WAN technology, whatever it may be. But everything costs money and time. Now, when we consider the sort of the practical steps, like how do we actually do, like how do we approach that conversation of building incremental improvement into an environment? I think a really good way to do it is tying it to asset strategy and asset lifecycle. So typical points that you're looking at is when you go and tender for a new site. So you're building a new greenfield site. The alternative is you've got a site that's 20, 30 years old, and maybe they're looking at doing a brownfield lifecycle. That's the sort of opportunity to start looking at architectural changes, because once the work is done right, it's set for another 20, 30 years. So being able to actually sort of step back from just an enterprise architecture perspective and actually work with the fixed asset teams, the asset management teams, the branch units, and actually understand what software are they running, what lifecycle state is it at, what's their plan to actually lifecycle that, and then you use that as the sort of point to inject yourself and actually build these changes into the program. And that's typically how this stuff happens. It's always like, my SCADA is out of date, so I need to life cycle. And then when they life cycle the SCADA, they chuck new switches in, they put new infrastructure in, all of that. That's sort of the cycle of how it happens in CI. The other component that really helps with this is the whole idea of a reference blueprint. So I spoke before about like file transfer and all that type of stuff, but you want to really focus on the high utility patterns is the key thing, I would say, because there's so many patterns you can develop. I really like SANS top 5 ICS critical controls as a sort of baseline for if you've got nothing and you need to start, well, just take the SANS top 5 and build those out as your starting blueprints. So incident response, so doing isolation, defensible architecture, how are you aggregating logs for visibility and monitoring? How are you doing remote access? So is there an architectural blueprint for remote access? Are you incorporating MFA? Are you incorporating like FIDO2 tokens or something like that? How are you doing vulnerability management? Maybe you need to have some sensors deployed in the OT environment, and then you aggregate upstream to your CMDB or to your IT vulnerability management platform. But I think if you just focus on those 5 things, you're going to get a lot of value. Then I already mentioned about when you go to tender, but I think acknowledge as well that a whole bunch of these systems are likely not managed by your organization. They're going to be managed by a third party. So there is a multi-component to this where you need to talk to third parties sometimes and actually build that. Like you have that blueprint, that reference blueprint for the organization, but then there's a conversation around vendor X is deploying a new system, and now you need to work through those SMEs to get them onto that blueprint. And the best time to do it is when you're specifying the contract, because once it's specified, you kind of can't do very much. So a couple anti-patterns and pitfalls I just want to go through. When I sort of enter a new environment and I'm thinking about where do I start, this is the type of stuff that I'm looking for as already anti-patterns that need to be addressed as part of these blueprints and as part of this uplift. So number 1 is identity. Identity is the biggest threat in terms of, and it's the biggest like indicator of compromise. Like in terms of what these threat actors are doing, it's all identity for the most part. So if you have shared identity or shared corporate and OT environment, is bad. You need to sort that out. And if you have a domain trust, same thing. There's transitional steps you can take towards that. Maybe as a starting point, you specify different credentials underneath the same. So you're on the same AD domain, but then you split out the credentials, and then strategically longer term, then you can look at actually building out a separate domain just for that function. So when I say these things, right, it's not this is bad, you have to rip it out. There's transitional steps to actually moving towards that defensible architecture state. The other one is shared IT/OT tooling. So when you're doing things like pushing patches from the IT environment straight into the OT environment, there's a lot of things can go wrong. You can knock sites out. I've seen it many times. Configuration management, again, from IT zones, that should be like those functions of privilege should be done from the OT. Internet to IT, or I guess internet to OT, remote access, also an issue. You should be looking at what are the methodologies that people are getting access to the OT environment. So that's a really telling sign. There's an idea of browse up administration as well, and there's a bit of a diagram on the right, which is basically your super admins, like these admins that have highly privileged credentials and they can access pretty much everything. So looking at those workflows and trying to really restrict who gets access to that. Are they using the same account for everything, or they have a special privileged account? Can you apply something like privileged access management on top of those accounts because they're highly privileged? And then the other one is management bypass, which is basically you have a God user going onto a God server, then the God server has access to everything. So being able to actually separate those roles out, for example, engineering configuration, you have a separate engineering workstation or engineering server for that. Network switches, you have a separate one for that. Identity, you have a separate one for that. So building out that separation is going to allow you to do that isolation better. And then just some general guidance, like these diagrams are from the NCSC Security Architecture Anti-Patterns white paper. It's a really good source to look at what not to do. And then on the converse, there's AEST, I think late last year, put out this secure connectivity principles for OT. That's quite good as well for what to do. So I'm just going to end on a worked example about, I guess, what does it actually look like to operate? Like once you've hit your target state, what does that actually enable you to do? So this is like a theoretical energy type provider. It's got connectivity to third-party grid providers. He's got your standard sort of IT/OT segmentation model going on here, and you've remote access from third parties and all this sort of typical stuff. And what I want to demonstrate is this idea of being able to island into sort of 3 different trenches. So trench 1 is the IT network, trench 2 OT network, or the OT management network, and then trench 3 is the local site control DCS, where the actual control equipment is. And this might be connected over like an MPLS network or like SD-WAN or something like that. So as a first scenario, we consider what does it look like when we have an internet-borne threat? So something like credential phishing or third party, or like an API endpoint's being popped, and then they've got an access to your corporate environment. So when you have this defensible architecture, you're able to make these these conscious decisions to degrade and isolate at key junction points. So if you have telemetry that's telling you that there's potentially an endpoint that's being compromised, then you might look at islanding IT to the internet. And you might do that for specific servers. You might do that for the entirety. In this case, they've got retail partners that they need to send data to. So in order to avoid that workflow being interrupted, they might island the internet connectivity, but they maintain that connectivity to their retail partner. So they're not interrupting that broader sense, as opposed to just saying, I'm going to turn off the whole internet. Now, if the end of the day, there's a compromise of corporate, there might be a consequential decision to then island the OT environment. So make that cutoff point there to contain that within IT and enable that process side of the business that actually generates the revenue and provides the essential services to continue to operate. All right. In another scenario, let's say that your actual OT management plane is compromised. So this sort of central control center aspect. Now, most sites are built, or most control systems are built to be resilient. So all the actual operating equipment's on site, it runs local control logic. It doesn't necessarily need to connect back to a control center. So you're able to isolate that site, allow that site to continue to operate while you actually address the threat here. People think about IT infecting OT. There's also the other way as well, right? OT can infect IT. So we also isolate OT from IT to prevent this moving to things like HR systems, ERP, that type of stuff. And then in scenario number 3, the last scenario, we've got like a site local network or a DCS, or it could be like a third-party network being compromised. So the impact is there. Now we're actually talking about real impacts to the physical process because PLCs are out, HMIs are out, that type of stuff. Here we want to prevent this one site infecting all of our other sites. So the question is, do we have the ability to actually isolate that site, prevent that from infecting our control plane, and also prevent that from infecting other sites that are running local process? We might also look at what sort of integrations do they have. So if that site has bespoke integrations to grid partners or some other third-party group, that might be part of the response as well, being able to inform that provider and then cut that connection off. And of course, there's this idea again of preserving safety. So generally you would put your SIS, your safety instrumented systems, into their own sub-zone. These are the things that basically, this is like the e-stop, right? Even though things can go wrong, the SIS prevents that from actually like physically damaging the asset. So you would look to disconnect an island, that local SIS as well. Okay, so in conclusion, yeah, so when you're doing architecture for critical infrastructure, you really want to start by workshopping those isolation use cases and rebuild use cases, and really inject that into any sort of design artifact that you're doing. You want to be looking for those anti-patterns. So is there anything that's being introduced that's compromising that ability to isolate or building unnecessary dependencies? So maybe there's a component and you put that component in Azure or into AWS. If that component can be run on premise inside of the environment, you're aiding that defensibility. If it needs to run in AWS or in SaaS or whatever, acknowledge it and just build out those degradation use cases to understand there might be a scenario where you have to isolate those environments and you're going to lose that connectivity. So what does that mean for the actual application? And then again, we're sort of moving away from this idea of prevention first. And so whenever you're dealing with CI, just think resilience first. And SRP is light in terms of what you should be doing when you're looking at critical infrastructure. And that's me. I think it's like 35 minutes, not too bad. I'll open up for questions and we can...
Spot on, Daniel. So I've got a first quick question for you before we, I think there is a couple already in the chat and then we can open up to everyone, but really appreciate your time. Obviously, one thing you're talking about is this might be 20, 30-year journey. You know, that seems like a lot of thought process. How do you start with your first steps of getting towards your target architecture?
So I guess just thinking first of all about a lot of CI aren't necessarily regulated. Some of them are. So if you're like energy, AEST, CSF, you're already getting regulated by AMO. So you're probably further along in that journey. And if not, then maybe there's a point in time where those SOCI obligations might actually apply. In terms of SOCI, the stuff I talked about, CI Fortify, the 3-month isolation, I think the date is July 2028. I think that's when they're proposing to do that. So, and it might be actually, I think even 2 more years. People were saying, oh, this is too hard. How are we going to be able to do this? So the government said, you get 24 months from the point that this becomes legislation to fix this. So understand, I guess, first of all, understand your obligations, right? And you want to focus on those critical systems and those priority applications. So there's a maybe you've got a business resilience manager or there's some asset management. You want to understand, I guess, where the priorities are and then focus your efforts on there. Generally, like I said, the control systems, this is generally your crown jewel where you want to start. I mentioned about the whole top 5 thing as well with SANS. I think that's also like if there's just all this work to do, like everything is just really hard. You just need to start with SANS top 5, I think. So how are you doing backups? How are you doing log management? How are you doing remote access? How are you distributing patches and getting visibility of the assets? So if you just start with that, you've got 1 to 2 years of good work to do that uplift, and then you can start looking at those strategic outcomes, those more nice to have blueprints later in the future.
Thanks for that. Okay, first question from Daryl. So Daryl, I hope I did this justice. What are your thoughts on the decision of Anthropic not to share my source work with critical infrastructure providers around the world?
So I think, like, I'm not sure the full context of, like, I know that there's guardrails around Mythos and who gets access to it. And obviously that is part of its marketing, right? They're like, oh, it's so dangerous. We can't put it out into the world, otherwise all hell will break loose. So there is that. I guess the question is, like, what would they do with it? I think we're at a very immature stage still with AI, and like I've been hearing about AI for such a long time in OT, and where like I saw like a Kubernetes environment the other day, or I started working on a Kubernetes environment in OT, and I was like shocked because I've never seen anything that's not VMware, and even going from bare metal to VMware was such a journey. So I think the pace is going to be slow. I think that there's a lot of value in terms of from 2 bits, right? So Mythos is obviously the whole that's talking about like using AI to do like cybersecurity, like insights and operations and that type of stuff. So, and then there's also the AI component to how do we do like automated factory? So how do we actually start making dynamic decisions using that? So look, it's probably the right move, right? I think the framework and the maturity to actually make the proper use of a product like Anthropic Mythos is probably not going to be best placed within like OT. But I guess you said critical infrastructure. So I do know that a bunch of critical infrastructure providers, like they are looking at using maybe not Mythos, but AI, embedding that into their IT SOC. So I think what we're going to see is the trickle down of that. So we're going to see some uptake in IT SOC using those agentic workflows, those agentic personas to actually start doing things like looking at like logs and investigating incidents. Like I said, that's the value as well, right? Because most of the incidents are going to come from IT and then pivot down. So yeah, I think it will happen eventually. And I don't know if it necessarily will be Mythos. I think there will be a time where we need to have that conversation. And the thing is, like, nothing changes. I don't think like it's like the more stuff we introduce, like at the end of the day, there's like the fundamental principles don't change. When we talk about introducing AI, it's all about creds and permissions. So it's, I've got this robot account, and for it to do what it needs to do, I need to give it permissions to write to an asset, to read from an asset, to look at my information, to get context. So it's the same principle of just understanding where is your information placed, what permissions are you willing to give, and then having that tiered architecture where if you're going to do it, maybe you want to put it, maybe you want to have it authoritated from inside the OT environment, not from the internet, something like that.
Daryl, I hope that covered what you're asking. Jackie O, I'm happy to read it, Jackie, or do you want to ask it yourself? Okay, what architectural considerations are needed in industrial clusters, precincts to improve trustability when enabling secure and trusted data sharing? Each organization has its own strategy, design, deployment, and vulnerabilities as well.
Yeah, so with, I guess when you say trusted data sharing, I'm not sure if you're talking about, because there's a component of IT sort of looks at OT in some cases as dirty when they're unmanaged. They know that they want to pull data out of it. So I guess if you're looking at it from that perspective, it's the same thing around building up those blueprints. So for example, you want to like what I'm doing is there's a case of like there's a whole bunch of unmanaged sites, and I want to get data. I want to be able to manage them and have that visibility, and inherently that means that I need to look at uplift. I need to look at a set of minimum requirements defining that. So, for example, before I connect that to my centralized network and manage it, I need to make sure that I've got at the very least like endpoint protection. I've got at the very least like a backup and recovery strategy. I've got a firewall in place, like just sort of like basic checks and balances. And you sort of have to work with your organization around what are the minimum set of requirements for me to, number one, connect that to the internet, or number one, connect that to my fleet. Acknowledging that once you connect them, there's the risk that that could actually infect your broader organization or the other way around. So I think you need to define a set of minimum requirements before you pursue that integration. Then you need to look to uplift that environment so you've established that trust. And then anything that doesn't work because of the bespoke nature of that site, where you're not able to actually map that to all the requirements of the blueprint, you have someone own that as a risk. You have an OT exception risk register, and you say, well, we couldn't do encryption on this data link because the hardware on site is too old and doesn't support it. But I've got that as a captured deviation from the blueprint, and I have made a decision to and it's not you that owns that, right? It's the architect. That's the business manager or the branch manager that operates that site, and they own that risk. And then once that's done, then you've established that trust to pull them in. And even though you have that trust, again, you have that ability to isolate. So you want to make sure that that's, at least you have that. So in the case that there is an issue, you cut that off. Yeah, I can talk about like some like mechanisms of streaming. There's a whole bunch, like you can do like MQTT. I've seen a bunch of people do Kafka. You can do like a file transfer, SFTP. Like you just have to build a standard, like whatever makes sense or whatever's going to work at scale. You just set that standard, and then you see, how do I get all my sites to align to that blueprint? If they align, then there's a level of inherent trust, and I can move forward with that integration.
Good for you, Jackie. Nicholas, you raised your hand.
Can everyone hear me?
Yeah.
Okay, perfect. Yeah. Firstly, thank you, Daniel. What a fantastic presentation. I work for CSR Limited, so we have a lot of industrial manufacturing sites around the country, and we've recently been acquired by Saint-Gobain, the French multinational, who do the same thing. And I just got a couple of questions to support, sorry, a couple of comments to support what you were saying, and then a question at the end. So I don't want to talk about what we did previously because it was pretty embarrassing, but since we've been acquired by Saint-Gobain, we've adopted the Purdue classification model for our OT and IT assets, and it's working really, really well. For Jackie's question, we have a thing called an SFEG, so a secure file exchange gateway that sits in the IDMZ between the IT and OT network, and that's the only place that stuff can get in and out, and that's working pretty well for us. But again, as Daniel said, you just have to establish a standard and then ask their other teams, with a bit of consultation, are you happy using these protocols to exchange data, and everything goes from there. You absolutely do need a program of work to roll this out. And takes a lot of funding, but because we had a global mandate to do it, we got funding from that, so it was fairly straightforward for us. But depending on your situation, it might be difficult to get that. But when managed properly, we had very few outages to production while we were rolling out the Purdue model, and it all went fairly well. To Daniel's point about the remote methods with vendors, our vendors were fine renegotiating their access methods. The way CSR used to do remote access with vendors and the way SG did were completely different. I mean, completely different. And all the vendors came to the party. There was no issues there. And the question I had for Daniel was, the one thing that's sort of confounding us at the moment is that a lot of these systems, we want to use the real-time data and we want to put it into a central data and analytics platform, and the global standards are all these cloud-based things like Snowflake, Fabric, Databricks, etc. And so what are your views and recommendations for getting data out of the E1s and things like that and putting it into those platforms?
Yeah. So I think it's some of the same as what you already discussed. So it's about building up a centralized pattern that can be agreed, and that is how we do that. And then you establish that capability, and then you look at how do you onboard sites, and you need to work with, I guess, the site people. So those key sponsors on those sites, whether that's the branch manager or an SME that knows most of the sites, you work with them to onboard them onto that process. Now, like from a technology perspective, typically historian is one of the methodologies that you can like that's like sort of inherent functionality. So I don't know if you have that sort of centralized historian capability, but I have seen organizations where, like I saw one recently where they pull all of their aggregate data into Skada, but then it's site Skada, and it's the question of, oh shit, now I need to aggregate that up into a nice packaged format. So if you don't have a historian capability, an engineering type solution like introducing historian and that same segmented methodology. So historians typically have that functionality to be able to do like local historian, and then you have historian in DMZ, and then you have a corporate historian that takes a subset of the data that you want to publish into your corporate environment. So that could be a pattern that you do. That's sort of native functionality, like a Viva Pi historian that used to be like OSI Pi historian, like that. That does that. I've seen other organizations, like I said, use Kafka. They actually establish Kafka topic mirroring. Again, it's the same idea. It's the same idea. If they've got effectively a data collector in the OT environment, they publish that to the DMZ, and then there's a mirroring process, and it's upstream. I think that's the key sort of fundamental aspect. You really want to look at making sure that it's upstream and it's not downstream. So if I'm pushing stuff out of the environment, I have no issue. There's the idea of sort of IT/OT sovereignty. So maybe there is an aspect to, do I want to push everything? There's also a cost associated with that. Maybe I just want to push a subset. So I guess if I was to summarize it all, build up a tiered upstream pattern to aggregate and push data out in a way that it can be easily classified, tagged, and understood. Select a technology and build up a architecture, maybe run a bit of a POC around what that looks like. Technologies like Kafka, Pi, like Pi historian technologies, like these types of things will let you do that. And then once it's in corporate, then it comes down to the technology, right? Like you might have like an adapter that reads from Kafka and then pushes that to your data lake. Or it might be that you've got there might be like a native like most native historians do some sort of integration with like ServiceNow or with some sort of like CMDB or some sort of like data lake function. So I think you need to work. You probably need to work with your vendors, like for what technology is going to make sense, but the underlying principle is the same. You want that sort of tiered replication upstream. You want the ability to disconnect that when you need to. And you want to have a good understanding of what data is leaving what data is leaving your OT environment and being replicated out.
Yeah, that's great advice. Thank you. I mean, it's less important for us to have the fallback because it's just for OEE and stuff like that. So if we lose, a couple of hours data, it's not the end of the world. Up at the data lake. But yeah, no, that's a really good idea. Thank you. I'll take that away and think about it.
It also depends on the classification of asset, right? Like if we're talking about like building controls networks or IoT sort of networks, then the model sort of changes. Like having that, like maybe you don't need that sort of that's a very ICS focused pattern. The whole like Purdue-esque aggregate to like a management layer 3 and then aggregate to like a 3.5 DMZ and then go into the IT. Like that's so if you're dealing with sort of more disparate data, maybe you actually can look at things like more of like a telematics type solution where you aggregate that directly to the cloud. And if you do that, then it's just about what other controls you're going to put in place. So maybe you can do things like Netscope SD-WAN or just something that you have the guarantee around, that you've got you're inspecting that traffic going up. So I think that sort of highly segmented pattern, like that's very specifically best for like high criticality ICS networks. So then if you're dealing with more like IoT building controls, that sort of stuff, then you can be a bit more flexible in terms of how you aggregate that data.
Okay, thank you.
Thanks, Nicholas. Great question. We're going to wrap up soon. I think we're going to find a question from Gregory, our man in San Diego. Hence why it's all dark there. With the increase in integration of LLMs into organizations' infrastructure and the speed at which AI is changing, what general set of safeguards or tactics do you plan or look at in striving to meet goals with resilience across organizations?
Yeah. So I think I've been doing a bit of stuff with LLMs, and one aspect to it, right, is that you can run your own local LLMs, or you can broker out to like a publicly available LLM. So, and there are guardrails around that. Like there are things that you can look for, like ZDR, is zero data retention, where in the contract, any data that I send out is there is a statement there to say that, oh, I'm not going to hold that, or I'm going to process it, that I'm going to dump it. Now there's a level of trust, right, to around saying, okay, I'm shipping it to an LLM. They told me that they're not going to store my data. You know, me personally, it depends on the classification of data. I wouldn't be too comfortable, you know, taking that at face value. So I think that most companies, like pragmatically, they're not going to build their own like local LLMs. That's something you could do, but I think most of them are going to leverage those third-party LLMs, which is fine, right? But it's just about getting an understanding of what you push out. Now, if we're talking specifically about like operational data and OT, I think this sort of tailors into like Nick's question, where building out the pattern, first of all, for how are we going to get the data out of the OT environment and into a data lake of some format. That's probably the first point before you even think about how do we ship it off to an LLM. How do we repeatedly get that data, the relevant data, out of the industrial control network and get that into a data lake that's corporate managed, and I can run analytics on it. And then from there, then it becomes a question of how do I integrate data lake to LLM. So I guess it's kind of new. I know it's happening. I think you just need to look at specific use cases, and like I said, it just comes down to like creds for the most part, and I guess what access to like what databases or what information are you going to allow. If you don't have a policy, I think that's a good starting point. Like even just building an AI policy and building up a bit of a like if I go to tender for a new project, like just having a checklist of, is there an AI component to this? Are we shipping data off to an LLM as part of like a third-party risk assessment, or as part of like a general just like checks and balance before you actually go? And at least that can start the conversation to see, because yeah, obviously there's a lot of stuff rapidly happening, and I think that's the danger, that we get too excited, then we sort of break all the stuff that we took ages to actually set up. So I think, yeah, Jackie just put that in the chat as well. I think policy is probably the pragmatic starting point. Policy and a bit of like a catch-all questionnaire supplier thing as part of like your GRC function, just to catch it and start the conversation, and then start looking at patterns for data aggregation and upstream transfer to a data lake in IT, and then controls for what goes out. And you can look at things as well, like I guess like I mentioned like Netscope before, but like I think if you have like a DLP type product, like that's a technical mechanism that you can potentially use. So if you can inspect the traffic, if every single user in your fleet has like a client, like a Netscope client, and you're able to inspect all that traffic, you can start doing enforcements like, I only want assets of this classification going to ChatGPT or going to Claude. So maybe you're using Purview, like Microsoft Purview, mixed with like a Netscope one with like a DLP policy applied. So yeah, there's technical ways to apply the controls, but probably best to start with policy in terms of how you like, what's your stance on what information you want and don't want going out to untrusted LLMs on the internet.
Superb. Thank you very much, Daniel. And we're on just over the hour, which is great. Thank you very much again for your time. I really appreciate that. That was an interesting insight, and I think something we haven't covered. DV4. I've got a recording, but I'll do a blog and get that out to all of you if you want to revisit. Next week, we've got Daryl and David talking about data. So if you want to join in that, that's always a bit of a comedy event around all things data, but really appreciate your time. Thank you, everyone, for giving up your lunchtime, and we'll see you soon.
Thanks, Andrew. Thank you, everyone.
Thank you.
Thank you.
See ya.
Thank you.